All right, number one, again, as I'm talking, if you had not grabbed a calculator, you're going to go grab one. Number one, we're going to start off just like normal. This bottoms-up method is a shortcut. Make sure all earbuds are put away right now. I do not want to see them in your ear. In order to do this, we're going to take, just like we did before, the exact same thing. 3 times negative 10 is negative 30. And I'm asking myself what two numbers multiply to give us negative 30 and combine to give us a 13. So I'm grabbing my calculator and I'm going to demonstrate to you what the process of my mind. So I'm doing it in my mind, but I want to show you with the calculator if you're a visual learner. So the first thing I'm going to do is I'm going to take 30 divided by 1. Well, 1 and 30 don't give me 13. I'm going to divide it by 2. Ooh, 2 and 15 could. 2 and 15 could result in a 13. So I'm going to write down 2 and 15. This tells me they're going to be different signs. If you've forgotten, this tells me they're going to be different signs. And this says the larger of the two numbers is going to be positive. So none of that is new. We've been practicing this. It doesn't mean you've mastered it. We've been practicing this off and on for the last 2 months. Now here's the brand new stuff. Are you ready? Please make 2 parentheses. I prefer this method because it's shorter. Anytime that it's shorter for me and I can master the process, I prefer that method. So the first thing I'm going to do is I'm going to take the 2 numbers that I selected. I'm going to write those down. X minus 2 and x plus 15. The third step, so step 1, choose my numbers. Step 2, write them in place. The third step is whatever number is called the leading coefficient. So that's the number in front of the x squared. We're always going to write that underneath each of the selected numbers every single time. Then you're going to grab your calculator, and some of you can do mental math in your head, awesome, and you're good at others want to use a calculator. So let's try, and I'm going to demonstrate if you're not good with mental math what you're going to do. Can everybody type in 2 divided by 3? Don't worry about the negative sign, and hit math, fraction, enter, enter. Oh, 2/3 does not reduce. Okay, that's good to know. This cannot be reduced. I don't even have to rewrite it. Now let's do the next one. 15 divided by 3, math, fraction, enter, enter. Oh, okay. I can rewrite 15 over 3 as 5. So x plus 5, and this has not been reduced. So my third step, step 1, choose a number. Step 2, write them in place with their signs. Step 3, see if you can reduce it. Now you have 1 step left and you are done. The third step says if there is a fraction, bottoms up. Take the bottom number and push it up in front of the entire expression. So 3x minus 2, there's not a fraction, I don't need to do it. X plus 5, and we are done. Let's look at number 2. Let's look at number 2. Step number 1, we're going to make our x 30 times negative 2. 30 times negative 2 is negative 60. So I'm asking myself what two numbers multiply to equal negative 60 and combine to equal 7. What two numbers multiply to equal negative 60 and combine to give us 7? And again, if you're not great with mental math, we're going to take this number 60, don't worry about it being negative, and divide by 1. Give me 1 second. 1 and 60 do not somehow combine to give me 7. Divide by 2. 2 and 30, that doesn't give me 7. Divide 60 by 3. 3 and 20 does not give me 7. Divided by 4. 4 and 15, I'm getting closer. 4 and 15 is getting closer. Let's divide by 5. Ooh, 5 and 12. If I subtract them, 5 and 12. 12 minus 5 is 7. So I like the numbers 5 and 12. This says they have to be different signs, and the larger of the two numbers has to be positive. That is step 1. Step number 2, make 2 parentheses. And the numbers that we just selected go inside. X, it doesn't matter if the plus 12 goes first or if the minus 5. You'll get the same answer at the very end. Same answer. Step number 3. I am going to come up and circle whatever was the leading coefficient. That's the number directly in front of the x squared. And whatever that number is going to go directly underneath the 12 and the 5 in this case. Okay, grab your calculator, please. let's type in 12 divided by 30 and hit math, fraction, enter, enter. Okay, it reduces to 2/5. Please write it down. And then I'm going to do the same thing with 5 over 30. 5 divided by 30. Math, fraction, enter, enter. X minus 1/6. So I kept the exact same sign. I just used the calculator as a tool to simplify. After we've done that, if we still have a fraction, we're going to do bottoms up. The bottom number goes up and in front. The bottom number goes up in front. 5x plus 2 and 6x minus 1. So I'm going to start off right now, and I'm going to go 6 times negative 4 is negative 24. What multiplies to equal negative 24 and combines to give us a negative 5? That's 8 and 3. The larger of the two numbers, because they're different signs, has to be negative. So the first step is 8x minus 8 and x plus 3. It would not matter if I put the x plus 3 first or the x minus 8. Whatever number's in front, even if it's a hidden 1. So even if it's like we don't see a number, it's hidden 1. We always take that and write that underneath. And then I grab my calculator, if you don't want to do the mental math, and that's what I'm going to suggest for this class. And I'm going to reduce 8 divided by 6. So I'm writing down x minus 4/3 and 3 divided by 6, x plus 1/2. Once I've reduced it, if I'm left with a fraction, then bottom has to go up. Bottom has to go up. 3x minus 4 and 2x plus 1. So the 2x plus 1 could go in front, and the 3x minus 4 could also go in back. So be honest with me right now, can I have a thumbs up or down if you end up getting it right? My goal is to be like half of us could get it right. Oh, that's pretty impressive. Okay, you ready? We're going to jump on to this next part. So we are now into the unit called rational functions. So we're dividing polynomials. Here's what I'd like us to do right now. I would like you to do bottoms up. If you need a separate piece of paper, you raise your hand and I'll bring one to you. I want you to do bottoms up for these 3, and I'm going to time you. Now these are easy because the leading coefficient is a 1. So some of you literally will be done in 30 seconds. It's true. But I'd like you to factor each one of these, and then I'm going to teach you what to do right now. So you have a little bit of space here. Please factor these 3, and I'll be right back with you. So I factored this top part, and you correct me if I make a mistake. I got x plus 5, and I ended up with x minus 2.
Yeah.
Then over here, I ended up with x minus 3 and x plus 1. Remember, the order doesn't matter. It could be x plus 1 first, it could be x minus 3. If you have not put them down on your paper like this, please do so. I'm going to say it again. Please rewrite them like this because we're going to take it a step further now. So you may have factored, but can you please write them down in this form? When I asked you earlier, just simply factor. I didn't say factor in a specific way. So please at this time rewrite them. So we've taken this form and rewrote it in factored form. And now we're going to take it a step further. This portion we're going to learn how to do by Wednesday or Thursday. We're going to start right now with just how do you factor this. So now we're going to use a method called 1 for 1. We can only cancel, really the correct mathematical term is going to be to simplify. We can only simplify one thing on top with one thing on the bottom if they're exactly the same. So can everybody underline your first one? Do you see any groups on top? There's 4 groups on top. So it doesn't have to be directly above it. It could be off to the side. Do you see any groups on top that are exactly like x minus 2? So 1 for 1, I want you to cross out x minus 2 on top with x minus 2 on the bottom. 1 for 1, that means if there was 2 groups on top, we can only cancel 1. Okay, is there any groups on top that are x plus 5? Okay, so cancel 1 group on the bottom with 1 group on top. And if you didn't know this, when we use the word cancel, again, it's not the correct math term. Really, they're simplifying to 1. So I'm going to go back and put a 1 in these places in just a little bit. And then x plus 1 on the bottom and x plus 1 on top, I get to cancel those. So each one of these, and you don't have to do this part, turns into a 1. So 1 times x minus 3 times 1 over 1 times 1 times 1. It doesn't just disappear. It turns into a 1. So on top, 1 times 1 times 1 is 1. On the bottom, 1 times 1 times 1 is 1. And I've just completed number 4. Number 4 is complete. Okay, we are going to look at number 5 now. We're going to look at number 5. You are all going to go into groups of 2. There may be a couple groups of 3. Let me go through this. I'm saying what multiplies to equal negative 15 and combines to equal negative 2. So I'm thinking of two numbers that multiply to give us negative 15. And so again, my thought process, if I use a calculator to demonstrate it, 15 divided by 1 and 15 doesn't give me 2. I take 15 divided by 2. Well, if it's a decimal, I ignore it. Divide by 3. Oh, 3 and 5 could give me a 2. So 3 and 5. The larger number has to be negative, bless you. And I write x plus 3 and x minus 5. And then this is the tricky part, remember, that leading coefficient is a 1. So I divide by 1, and then I use a calculator and I get x plus 3 and x minus 5. I don't want to be confused, so I'm going to cross this out. On the bottom, I'm going to write x plus 2. I do not want you to do the next part. I only want you to watch. Your eyes are up here, please. Okay. I'm going to do the next part that I'm highlighting. I do not want you to do it. I want you just to watch. Watch me do the next part. 2 times negative 2 is negative 4. What multiplies to equal negative 4 and combines to give you positive 3? This tells me if you're listening. Turn to your partner. Most of you have partners of 2. Some of you have 3. What two numbers? Turn to your partner, not to me. 1 and 4, but what are the signs? Which one's positive, which one's negative, and how do you know? Negative 1, positive 4, the larger number has to be positive. So I'm going to write down x minus 1 and x plus 4. And here's why Mr. McFarland hated this method. Because too many students would do this, which is great, but they would forget that that leading coefficient has to go on the bottom. And then you grab your calculator, and I go 1 divided by 2. Don't worry about the negative sign. I simplified. Okay, it does not simplify. And then I go 4 divided by 2. Oh, it simplifies to a 2. So once I put it into the calculator and I have attempted to simplify, if there's any fractions left, we do bottoms up. So I'm going to write this now. I'm going to replace this numerator with 2x minus 1. Please write this down. 2x minus 1 and x plus 2. So I just did the numerator, and this is what I came up with. What I would like you to do right now is somewhere off to the side, don't do it right here, somewhere off to the side with your partner, and guess what? We're going to do 2 additional problems today when it comes time for homework for the groups that don't work together well. I don't care about right or wrong answers, I don't care about speed, I just care that you are working together. Please use the bottoms up method to factor this. Do the Here we go, you ready? So for this problem, we're going to have a competition after this. What multiplies to equal negative 6 combines to give you 5. That competition will determine what kind of homework you have. What? Did I write this down wrong? You just what? Did I write it down wrong? No. What multiplies to give you negative 6 combines to give you 5. Homework, like we're not in elementary. Come on, guys. The two numbers, different signs would be 6 and 1. The larger of the two numbers has to be positive. So I like x plus 6 and x minus 1. But what do I have to remember to do? I saw so many people, even now when I was walking around, that didn't do this. What do I do next, Andy?
We put
Yep, and a lot of students say, which one does it go underneath? It goes underneath both. Then I grab my calculator, and I plug it in, and I got a 3, and I still got a 1/2. Doesn't mean you did it wrong. Anything that has a remainder of a fraction gets pushed up. So one of these groups is 2x minus 1. It doesn't matter if I write it first or second. Now let's look. We're going to do this next part together. Are you ready? Here we go. Is there any group on top that is x plus 2? It's 1 for 1. 1 for 1. So if I cancel 1 on the bottom, can only cancel 1 on top. They have to be identical. Same signs. Is there any 2x minus 1? Yes. Is there any x plus 3? Yes. Now, what do each one of the ones that I made little squiggles through, what do they actually turn into? So 1 times 1 times 1 is 1, and I have an x minus 5. 1 times 1 times 1 is 1.